Welcome to one of the last sessions of the OSCON conference. It's above. Relaxed. Really formal.
Beautiful slides. Sorry, go on.
Deirdre, why are you closing your ears, Deirdre?
So I can hear from the headphones and not outside.
Okay, I'm not telling any more jokes. So welcome to the BOF, one of the Sun BOFs on security. And we have an impressive lineup compared to the number of people in the room. So the goal of this BOF was really to present some of the technologies that we have in Sun Solaris in open source that you can look at, that you can use, learn from, contribute to, but not just to present them, but also to get some feedback from you of which of these are actually useful, what features might be missing, novel uses of these that we haven't even anticipated yet. So we really wanted this to be sort of a kickoff for a discussion. Now, since there's not that many of you, the discussion will be just sort of be in a small circle, but I hope constructive and definitely intimate with that few people. So the participants today, basically the folks you see up here, more or less in order. So Valerie is giving the first presentation on the cryptographic framework. Then Scott Rotondo is giving a presentation on the process rights management. Everything will be very high level, introductory and brief. Glenn Faden is going to talk about security in Solaris containers, so the whole containment concept of OS virtualization. And then Glenn Barry is not actually giving a presentation, but he is our Kerberos guru, so he's here for additional questions in case you want to learn more about Kerberos. And
our audience just tripled. Awesome. I'm ready to go.
good. Here we go, Valerie.
Hi, my name's Valerie-Fenwick, and I work on the Solaris Security Technologies Group. I've been at Sun for a long time, working as a developer on lots of different things, and firewalls and tests. And my latest project I've been on for the last 5 or 6 years is the Solaris Cryptographic Framework. And I do have beautiful slides, which you can see on a laptop over here, or Christoph can show them. He'll be our spokesmodel. Christoph is running away. So the cryptographic framework is based on a standards-based pluggable cryptography thing. So we use, anyone know, I'm going to stand up. I feel kind of weird. Sorry, Deirdre, if that screws up your camera. But if anyone know PKCS11? Anyone? Okay, all right, Tony, you better. Okay. So it's a RSA standard that is used for cryptography. It's kind of Microsoft centric, Windows kind of centric, but it works on any platform, and we've adopted that so people who have written PKCS11 applications elsewhere will be able to port them to Solaris very easily. So we have a user land and a kernel interfaces. So if you write kernel programs versus whatever applications, all works. It's an administrative policy, so let's say you go, you know what, I am sick and tired of people using MD5. You can turn it off on your system and nobody gets to use it. Some people may get mad and angry and stuff like that, but you can make them use SHA-2. That's the kind of policy you can set system-wide. And we also provide end-user commands, which brings cryptography to the general person. So you can encrypt data with the encrypt command. You can do digest to get hashes, and pktool to do some basic administration of your key store. So now I'm going to talk about libpkcys11, which is our library interface for this. This is the user land side. This is really the user land cryptographic framework. Applications link to libpkcys11 using the -L when you compile your code, and gives you access to all user land providers as well as kernel providers. It provides a unified slot list, and different slots can be from different vendors. There's no guarantee about slot order, except for one thing I'll get to later. But calls are all redirected to underlying providers, so you don't have to know everything that's on the system. It makes your applications much more portable. It doesn't matter what crypto is there. And all the errors go into syslog. So Sun provides, just so that you don't have to depend on someone else for giving you crypto out of the box, Sun provides cryptographic software-based algorithms right out of the box. These are all optimized to different hardware platforms, both platforms that that Sun makes, the Spark line, as well as AMD 64 and Intel platforms. So we want to make sure that no matter what system you're running Solaris on, you're going to have the best and fastest cryptographic algorithms available at your disposal. But we make sure we give you some by default, even if you don't have any other plugins. We also give you an on-disk encrypted persistent key store and access to hardware crypto as well. For example, the UltraSpark T2 comes with a cryptographic chip, and you get access to that even from the user land. So, for example, SSH takes advantage of this hardware accelerated crypto for doing large data transfers and things of that sort. And there's something called the Metaslot, which is a unified list of all the providers. So you as an application developer who might say, I don't really want to, especially want to make it portable, you can always just kind of use the Metaslot if it's available, and it's only available if there's more than one provider, which kind of makes sense. And it will just kind of give you the best and the brightest of everything. So this is a pluggable cryptographic framework, which is what makes it really cool, and that other vendors like Ericom and Cipher make cryptographic cards, and they just provide a driver. It gets cryptographically signed from us, and then it just plugs into the framework. It just works. The kernel side is also pluggable, and we have a kernel-specific API that's PKCS11-like, but it's different. It's more for asynchronous operations, synchronous things, and different type of kernel things that are not applicable to user land. And if you want to make your own, unfortunately, due to some U.S. export regulations, you can't just plug anything in. You do need to get a certificate issued from Sun. It's very easy to get. There's a command called elfsign, and that has a sub-option called request. So elfsign request gets you that, and you send in the request to Sun. We send you back a certificate, and you're plugging away. And so the current OpenSolaris consumers of the cryptographic framework are libsazzle, IPsec, IKE, CIFS, Kerberos, both userland and kernel, wireless drivers, SSH, OpenSSL, KMF, Java JCE, kernel SSL, encrypted Lofi, and Firefox. And that is all. All right.
Oh, I think you might have a question there.
Oh, yeah. Question. Okay, yes.
Hardware support. I'm a real skinflint, and I don't like to spend thousands of dollars on certain large multinational corporations' crypto hardware. What's support for like a third-party, much cheaper crypto chipsets like is it HiFi or Heine or HIFI?
I'm not familiar with those particular ones, but I know like via keypad and stuff like that. They are because we are an OpenSolaris project now. People can develop drivers for this. Like I said, it's PKCS11 for the userland side, which is very common. And usually all they need to plug in is to get a certificate from Sun, which is exactly like what happened with like NCipher. They already had a PKCS11 library to access their hardware. Okay. They just got a certificate, signed it. Boom, it's in the framework.
Okay, great.
So if you want to work on developing some more stuff for cheaper hardware, then we would love to have you on board. And at the end of the presentation, which you can't see, you can see that there's an alias called crypto-discuss. I'm also on Twitter at Bubba, which would make a lot more sense if you could see my maiden name, which is Bub, but you can't. But I can give you a card.
Okay, great.
Mm-hmm.